Hi everyone, I'm Jacob, and I'm happy to share with you some of the work that we have done in the Molopo Farms Complex. Today my talk is entitled Sulfide and Silicate Textural Relationships in the Disseminated Ni-cu-pge Mineralization of the Molopo Farms Complex in southern Botswana. Let's start here. The Molopo Farms Complex is located towards the western margin of the Craton, and the Bushveld complex is just about 200 kilometers to the complex. Now, the difference between the two is that the Molopo Farms complex is poorly exposed, and the only available exposures are limited to the pens like the king pen. And the complex is also intruded into the sedimentary units of the Transvaal supergroup into which the Bushveld is intruded, and the available geology is made possible through the study of drilled cores and some geophysical work. The Molopo Farms complex is composed of a large proportion of ultramafic rocks compared to the overlying mafic rocks. Now, if we look at, in details, we look at the stratigraphies of the two complexes. We have the Bushveld complex to the left and the Molopo Farms. One of the striking differences is that the critical zone in which most of the PGE reefs are found in the case of the Bushveld complex have not been intersected by the current boreholes, available boreholes. So the mineralization that is we are studying in the Molopo Farms complex is based on is found within the ultramafic complex. It's entirely within the ultramafic rocks. So we have documented the occurrence of PGE minerals, the mineralogy of silicates, as well as also the geochemistry, and we try to put this data together to constrain the nature and origin of this disseminated sulfide. This is one of the boreholes that we have studied. It's drill core number TB11, and it contains interlayered hasbargites and feldspathic orthopyroxenites, which are demarcated by orthopyroxenites. And the black bars here represent portions whereby we can see the disseminated sulfides in the drilled cores. They are confined to the feldspathic. And this is the Transvaal supergroup units onto which these magmatic rocks are sitting on. If you look at the petrography of our units, this is the dolomitic siltstone of the Transvaal supergroup, which is pyrite bearing, and between this dolomitic siltstone and the marginal norites, we have some occurrence of chilled margins, and this is the feldspathic pyroxenite, which is hosting most of the sulfides, visible sulfides, which is marked by the presence of intercumulus plagioclase. And this is some of the sulfides. The point I really wanted to make in this slide is that the magnesium number of the orthopyroxenites, orthopyroxenes from the hasbargites are extremely high, and as we can see it from here, 85 to 93. And this is basically higher than currently established for the B1 parental magma composition. And this perhaps suggests a more primitive parental magma than the B1 Bushveld composition. Now, this is the platinum group elements, platinum group minerals. We've got mostly the palladium and platinum bismuth tellurides and some electrum. They are mostly small grains, mostly less than 20 micrometers, and they are found at the margins or at the edges of the sulfides, and mostly they are in the altered silicates as free grains. Now, this is a close look up at some of the sulfide textures. We have sulfide globules, and we have some of which are kind of flattened, like these ones here, and there's no really apparent silicate caps on these sulfides, and we also have some of the textures like these ones, where we have the sulfide aggregates with which are enclosing some of the plagioclase. This is plagioclase here, and this one we have the sulfide aggregates which encloses the orthopyroxenes. If we move into the lithogeochemistry, one of the similarities of the Bushveld and Molopo Farms Complex rocks is that it seems like the modal mineralogy of these rocks are controlled by, the chemistry is controlled by the modal variations of orthopyroxene, plagioclase, and olivine, and there is less contribution from the clinopyroxenes. And the orthopyroxenites which occur between the Hasbergites and feldspathic pyroxenites are characterized by this kind of trend, which is helps due to accumulation of chromite. And from the feldspathic pyroxenite themselves, we see this kind of trend, of course, which we interpret, or it means that the presence of the sulfides. If we move on to the patterns of the platinum group elements across all the drilled cores that we have studied and all the different rock types, we see the same pattern, which is characterized by enrichment of iridium to copper, elements from iridium to copper. And the highest grade is of palladium and platinum together with gold is around 0.47 ppm, and whole rock nickel we have up to 0.38% and copper 0.12. But one of the differences also with the typical Merinsky kind of platinum and palladium ratios is that here in the Molopo Farms Complex, they are mostly less than 1, and this is similar to the Blood Reef and not the Blood Reef for UG2. Now, we are looking at the Molopo Farms Complex, which is located at the western edge of the Kaavera Craton, and this is also. Then we looked at what kind of the major fault systems are available. We've got the Pomudika lineament. We also have some of the Weda-Kari shear zone as well as the Jwanema-Popon shear zones. And the Pomudika lineament is thought to be atmospheric in extent. And also, et al. In 2012, they have proposed that there are feeder dikes along the Jwanema-Popon and Weda-Kari shear zones. That is along these two structures here. And we also see that in the total magnetic intensity anomaly map of the Molopo Farms Complex. This is here the Pomudika lineament, and here it is branching into two. We have the Weda-Kari and the Jwanema-Popon shear zones here. But if we now look at some of the possible mineralizing processes, we've looked at the element ratios to evaluate the crustal contaminations. They are most characterized by some kind of homogeneous contamination of all the rock units, including those which are not close to the metamorphosed sedimentary rocks. And the delta sulfur 34 values of the country rocks are from minus 4.1 to 0.6 per mil, while the magmatic rocks have broadly negative ones from minus 6.3 to minus 11. Now, if we consider this in terms of a model, we put together this kind of schematic diagram here, and we have the Bushveld complex around here, and this is the Kaavera Craton, which is actually modified by the Bushveld magmatic activities. Then we have the Molopo Farms Complex here. We think that the main Bushveld plume was diverted from the thick cratonic center towards the margins where the Molopo Farms Complex is, and where the Craton is less thick. And the crustal axis of the Molopo Farms magmas were perhaps aided by the Pomudika lineaments and the feeders, which was suggested by Walker and co-authors. So we looked at the sulfide textures, and then we looked at some of these textures where we find the fragments of feldspathic orthopyroxenite within the Hasbergites. Then we tried to come up with a model to explain what we are actually looking at. And we think that magnesian magmas, possibly of B1 composition, which are represented by the feldspathic orthopyroxenites, reached sulfide saturation perhaps before the final Molopo Farms Complex magma chamber. And we think that the crustal sulfur is likely from the Ramuzwa shales in the Transvaal supergroup in the southwestern part of Botswana. And then sulfide saturation and sulfide segregation might have occurred before the magmas were placed into the final chamber. And the same magnesium B1 magma of B1 composition then flushed some of the sulfide globules perhaps to the current chamber. Then when the contents of this staging chamber were crystallized, we then have the magmas which are more magnesium than the B1 composition, flushing some of the feldspathic orthopyroxenite here, which are represented by the occurrence of fragments of feldspathic orthopyroxenite within the Aspergites. And this model, we think, it will adequately explain the homogenized contamination of all the units, even those that are not directly below or in contact with the metamorphosed contact rocks. That is about all we have. And some of the key takeaway messages are that the high magnesium number in the orthopyroxene seems not to suggest that magmas from which the Molopo Farms Complex crystallized became more evolved as they flow laterally from the early formed bushveld magma chamber. And then the homogenized crustal contamination of all the rock types, including those not in contact with the metasedimentary rock, suggests that crustal contamination may have taken place before final emplacement into the final Molopo Farms Complex chamber. And then based on the sporadic occurrence of sulfide globules, the presence of the fragments, the Craton margin setting, the possibility of the sulfide mineralization in the feeder zones of the Molopo Farms Complex should not be underestimated. That's all, and we would like to thank our sponsor, the Japan International Cooperation Agency, JICA. And there's a paper coming up where we kind of summarized this, some of the results we have so far. If you have any questions, any discussions, suggestions, feel free to drop me an email. Thank you.